So another limit on page 107. Let's pick, let's say, 44. 44 on 107. So we will get there. If you trust me and you do what I ask you to do every day, we will get there and we will be successful. And that's my target for every one of you. So x approaches -2 from either side, from 2 minus the absolute value of x, everything divided by 2 plus x. Ready? Okay. So where is the starting point? And no, I can't plug it in just now. I have to simplify this function fully. Don't even look here. Just look at the function and say, where do we start? Which part do I have to start with? And the answer is absolutely, the absolute value. Exactly. So the absolute value of x. What are the options for the absolute value of x? X, very good, for x being
greater than 0
or equal to 0.
negative x
And negative x.
for x less than 0.
Awesome. But this is just this piece. We only discussed this piece. But now I want 2 minus the absolute value over 2 plus x. So if this piece in here has 2 options, then the entire function must have 2 options. What is the first option?
2 minus absolute value of x.
No, I'm done with the absolute value. There are 2 options for this. The first option is x. I cannot jump to the second one just yet. The first option is when the absolute value of x is x. What do I get? 2 minus x over? Very good. If? Excellent. Very good. Awesome. Now the second option, please.
2 plus x.
Very good. 2 plus x over?
2 plus x.
Very good. If?
X is less than 0.
Careful.
And x is less than -2.
X must be less than 0, but not
Not negative.
excellent. Excellent. Yes. X less than 0, however, x not equal -2. Can anyone explain why x cannot be -2?
Because the denominator would be 0.
Right. Right. Very good. Awesome. Perfect. So now I go back to the limit. The limit says find the limit of this function. I'll see which branch when x approaches -2. Where is -2? Is -2 in this domain or in this domain? You can say it's in neither, right? It's not there, it's not here. True. But since I have less than 0, obviously -2 is somewhere in this interval to the left of 0. Perfect. So then I will have to find the limit as x approaches -2. And we didn't simplify. So can anyone give us the simplified form of this? Very good. So the limit as x approaches -2 from this function. And what is the limit? 1. Do we understand these kind of limits with absolute value? Yes, please.
What is it? 2 plus x over 2 plus x.
How much is 2 plus x over 2 plus x?
1.
Very good.
Yeah.
Only if x is not -2. Say it again.
Where did that come from?
Which part?
2 plus x over 2 plus x.
So let's go back to the function. So this piece has 2 options. When it's the first option, I have this. When it's the second option, 2 minus -x
2 plus x.
will be 2 plus x.
And 2 minus x.
So when the
Do you not
absolute,
plug in for the denominator?
but there is no change. I cannot change 2 plus x.
So it's only
There is
2
no absolute value.
Okay.
So 2 plus x is only 2 plus x. Was born 2 plus x, will die 2 plus x.
Okay, makes sense.
We can't make any changes in 2 plus x. The only piece that has 2 options for everyone to understand this. It's a very good question, actually. So in this function, only this has two options. 2 cannot be changed, 2 cannot be changed, x cannot be changed. Only this piece has two options because of the absolute value. So therefore, the function has two options, this or 1. Is this better? Yes, everyone? Okay, so is that clear why the limit from either side of -2 is 1? Not clear? Robbie?
Slight question. So because x is approaching -2
From either side,
from either side, yes.
the function doesn't have to be defined at -2.
Right. But what I'm asking is, because it's approaching -2, and if the negative you chose is less than 0, can't you just ignore greater than 0 as a possibility, or is it just good practice to do both anyway?
Oh, very good question. Okay, so your question is this. Why do I bother with a part that the limit does not ask me to calculate?
Because judging off of this, it appears that it's just good practice.
It's a perfect question. It's a perfect question. I would not know from the very beginning. If I don't analyze the function, I may not know which branch to pick.
So it can change.
So I highly recommend analyze the function first, simplify it fully. So the function is simplified completely into this or 1. That part, you may be asked to determine both.
Okay.
Something with 2 questions. For greater than or equal to 0, whatever, and for to the left and right of -2. So I recommend always analyze the function and simplify it fully before you give the answer. It's a very good question. Thank you. Anything else here? Okay, do you think we need to look at another function? Or are we happy with this? I'm looking to see if there is anything else that I would like to do because your question was so good. I would like to do number 5. Okay, let's do number 5 and then we'll start. So this is number 5 on the handout. And we can check that from the handout as well. So limit as x approaches 4 from the left of the square root of 16 minus x squared. So Robbie's question triggered this in my head immediately because he is correct. He said, one more time, he said, why would I bother to analyze the entire function when the limit is asking me to determine the limit from the left and from the right of -2? So why do I look at the whole thing? Okay, here's an example. Why I have to look at the whole thing. So for example, here you would say, oh, I know this. I'm just going to swap the 2 operators. I'm going to take the square root outside and put the limit inside. No, you can't. Why is that? Because first thing we have to do for this kind of limit is we have to find the domain. We have to find the domain of the square roots. So this is a very important topic, and I need to refresh your memory on how to find the domain of a square root function. So let's say disregard the limit for a moment. That doesn't even exist. So I'm given this function, and I am asked to find its domain. Okay, so what do I have to write in order to find the domain of such a function? This is a fun fact, fun in quotes. I still have to find a student who likes a radical function and who will say, oh, it's easy, you have to do this. I still have to find one. For some reason, no one likes the square root. We are all biased against the square root. Okay, so does anyone remember what type of number do we have to have under the square root for the square root to be a real number? Or, of course. So 16 minus x squared must be a positive number or 0. Otherwise, I would not be able to take the square root from it and get a real number. It would be imaginary. Good. So Finding the domain of this function reduces to solving, what is this? We have to identify it, solving what?
Inequality.
Oh, yes, an inequality of what type? You can call it polynomial, but it's polynomial, but it's specifically what type? Quadratic. So this is a quadratic inequality. Very good. Okay, so we established that in order to find the domain of such a function, I have to write this inequality, and now I have to solve it. It's a quadratic inequality. Anyone remembers how to solve a quadratic inequality? What is the starting point? What do I need to do? And please do not say, separate the terms and take the square root. Let's write this as a note. Note, never take square roots from both sides of an inequality. Unless you know that both sides are definitely forever what? Positive. Comma, unless both sides are positive. Forever. Not sometimes positive, sometimes negative. Always, always positive. Are positive. Which will happen in this class. You will see later on when, how. Okay, so then I still have the inequality 16 minus x squared greater than equal to 0. What do I have to do? Say it again. Nope, we are not going to separate the terms. Yes?
Change the inequality to equal.
No? Yes. Awesome. But first, I will present it in descending order. Negative x squared plus 16 greater than or equal to 0. Now there is something I don't like about this, and you'll tell me what it is that I don't like about it. Exactly. I don't like a negative leading coefficient, ever. What should I do to both sides to eliminate the negative leading coefficient? Yes, multiply or divide, both work in this case. So I have x squared minus 16, 0. Thank you. Now I'm ready to factor. Awesome. So all these steps are for your notebook if you created one. If you didn't, it's up to you, whatever you need to do to remember this. I will put it on February the 12th. Today, we refreshed our memory on how to solve a quadratic inequality. I'm not allowed to separate and take square roots. I have to set the inequality, make sure that the leading coefficient is positive and factor it, and so on and so forth. This is a long procedure. Okay? Good. So the next step is the factored form, which is?
X plus 4x minus 4.
Awesome. And now I will recommend a table in which we summarize what we are trying to do. X is the variable in the problem. Variable in the problem. It can be anything from negative infinity to infinity. The first factor in the problem is, which one? What do I write as the first factor?
X plus 4.
Excellent. What do I write as the second factor?
X minus 4.
And what am I really, really interested in studying the sign for? I'm not interested in this. I'm not interested in this, but I'm interested in the whole thing. I'm not interested in this. I don't care for this. I'm interested in the whole thing. So the last row must be what I am really, really interested in. Not the first factor, not the second factor. I'm interested in the whole thing, the product. Is that clear, everyone? Good. So now I would like you to tell me, where is this quantity 0? When x is? When is this quantity 0? When x is? That's all I need in the table. So please tell me, where do I put them? Which one is first? I put -4 first, and then? Very good, awesome. So x plus 4 is 0 under which of these again?
Negative.
X minus 4 is 0 under? Excellent. And now please tell me what you get here and what you get here for the whole thing. Do you all agree with 0 in both cases? If any of them is 0, the product must be 0. Would you agree?
Yes.
Good. Now all I want you to tell me is the sign. In other words, plug in a number here and tell me the sign. Do you all agree? Plug in -10 and tell me the sign. Good. Let's plug in 10 and tell me the sign. Same thing for this one, before it gets to be 0. Plug in any number you want and tell me the sign for x minus 4. Plug in a number to the right-hand side of 4 in x minus 4 and give me the sign. Perfect. So now, I see 3 subintervals. 1, 2, 3. On the first subinterval, I multiply 2 negatives. I need the sign. On the next subinterval, the first quantity is positive, the second quantity is negative. I multiply them, the sign. And on the last one, both are positive. Perfect. Now, I look back and I ask myself, which sign is less than or equal to 0, because that's the one I need to pick. There is only one sign. We only have 2 signs. Which sign is less than or equal to 0? Which of the 2 signs that we have, which number will be less than or equal to 0? A positive number or a negative number? Good. So let's take a look. Is this product ever negative?
Yes.
For which x values is negative? What do you think this is for the function? Exactly. One more time. Let's do this at the final discussion one more time. I'm solving this inequality. I studied the sign of each of the factors, and therefore I studied the sign of the entire product. I realized that on this subinterval, the product is positive. On this subinterval, the product is negative, because one is positive, one is negative. When I multiply them, I get negative. And here it has positive. And now I come back to see what I pick. Well, I want this to be negative, because if this is negative, it's less than or equal to 0. So I will have to pick this territory, if you want, or where the product is negative, meaning I have to pick between -4 and 4 as the domain of this function with the brackets, because 0 is allowed. After all this work, I finally go back to the limit. And the limit says, find the limit as x approaches 4 from the left. Is 4 from the left in the domain of the function? 4 from the left with numbers smaller than 4. So then I can now plug in 4. I didn't know whether I was allowed to. And I also wanted to show you how to determine the domain of a radical function. So what is the answer? Indeed, very good, awesome. What if I ask this question now? Find the limit as x approaches 4 from the right of the square root of 16 minus x squared. What would you say? DNE. The function doesn't even exist to the right-hand side of 4. We determine that by finding its domain. On the right-hand side of 4, the function does not exist. So now what if I ask, find the limit as x approaches 4 from either side? Of course, one of them is 0, the other one does not exist. From either side is DNE. Do we understand the concept of determining, or the process of determining the domain of a square root? Yes, please. Timo? Yes? Because that's what it says. This inequality is asking us to find the x values that make this product less than 0. If I had greater than or equal to 0, I would have chosen the positive. But I have less than. That's what I was asking. Which sign is less than 0? Negative. So I have to pick the negative. And picking the negative gives us the domain between -4 and 4. If this were greater than or equal to 0, I would have picked between -infinity and -4, union 4 to infinity. Better? Yes? Okay. Any questions on this? So keep the limit handout handy, because we're going to continue and finish those as they come up. Any questions? Mark, do you have a limit handout? You do?
I don't believe so.
You do?
Yeah.
Okay. Very good. Moving on. The precise definition of the limit. Yes, I will see you on Thursday, but please watch. Yes, your homework. Yeah, thank you. I think you gave me this too. Perfect. Okay. Let me explain the concept a few times before we are ready to write it down. This is basically the only proof that we are going to work on in this class. And we're only going to work on linear functions. So it's not going to be anything complicated. But you need to see this proof in this class as the only proof, really. We're not going to prove anything else. Okay, so what does this mean? The precise definition of the limit. So here is a function, limit of x plus 3 when x approaches 2. What would you say?
5.
We all agree with that. It's a polynomial. I'm allowed to plug it in and I'm done. Agreed? Okay, perfect. So is there more to this? Isn't this enough? Isn't that clear? It's fine. Yes, there is. There is more to it. And let me graph this function. So the function is x plus 3. When x is 0, y is very good. And when y is 0, x is when y is 0, negative. When y is 0, negative 3. Is that clear? When x is 0, y is 3. When this is 0, I have to move 3 to the other side, and I get x equals negative 3. Agreed? Okay, so here's the graph. Okay, so it's very clear. As x approaches 2 from either side, the function values approach 5 from either side. The function doesn't even have to be defined there, but it's a linear function, so it is defined. Good. So here's the concept. Let's suppose I create a symmetric interval around 5. And let's say symmetric meaning from 5 I subtract a little bit and I add the same quantity. And it will be a symmetric interval around 5. So I'm going to call this piece, right, this point I should say, 5 minus epsilon. And what will this piece be then, if the interval is symmetric? Very good. So I will continue with horizontal lines from those two. Those horizontal lines meet the function in 2 points. I hope you agree. And then at this point, I will bring down a vertical. And from this point, I will bring down a vertical. So let me ask you this before we continue. Would you agree that no matter how small I make this epsilon, I can make it 0.1, 0.2, 0.5, how small or how large, I will always be able to, corresponding to that epsilon, I will always be able to find an interval around 2. Right? Would you agree? Because the limit exists, right? So if I make it this big, or if I make it this big, or this big, I will always correspondingly get a corresponding interval around 2, right? So if I have this epsilon, 5 plus epsilon, 5 minus epsilon, I get this. If I have a smaller one, then I would get this interval. But I will always find an interval around 2. Agreed? Okay. So which of these two distances is smaller? Oh, I know it's a silly question. The left one or the right one? Okay. So then I will choose a symmetric interval with this width, the smaller of the two. I will call this 2 minus delta. And of course, I will call this, what do you think? 2 plus delta. So now you can say, so you started with an epsilon, fine. You determine an interval around 2. Now you're chopping it up. Instead of using the larger one, you're using the smaller one. Because I have another option, right? I have the option of this length. However, I'm not going to choose the wider of the two. Here is why. If I choose the wider of the two, what about this x? For this x, the f of x will not fall within epsilon, away from 5. That's the problem with the larger interval. So if I use the smaller interval, any x I pick in here, let's say this x, I cannot pick 2. Can I pick 2? Because x approaches 2. If I pick this x, then I'm a little bit off. So if I pick this x, then f of x will be within the interval that I started with. But if I pick the larger interval, look what happens. It's outside. So when I have to make a choice, I will always choose the smallest of the two, the smallest width. Okay. Such that when I pick an x close to 2, the corresponding f of x, above or below, my graph is not perfect, the corresponding f of x will fall, we say, within epsilon away from 5. Okay, so you can say, wonderful. What do you do with this? Here's what I do with this. I show that the limit exists because I can make the epsilon as small as big as I want. For any epsilon. For any epsilon, I will find the corresponding delta around 2, such that when I pick x here, f of x will fall within epsilon away from 5. And what is the purpose of this? This means that the limit exists. Let me give you a counterexample before we write the definition, and you'll understand what I'm saying. Here's an example. Here's our 2, and let's say here's our 5. And you can say, oh, the limit exists. Because if you use this epsilon, which one is the smallest? This is the smallest, let's say. You can always find a delta. 2 plus delta, 2 minus delta. You can always find it, and then when you pick an x, they will be within epsilon away from 5. Right? The limit exists. Not so fast. The key is the word for any. Does this limit exist for any epsilon? No. Here's the problem. If I make or I choose this epsilon, I will never be able to find an interval around 2. No, there is no open interval around 2 because these two will hit here and then you're going to have just a vertical line because the limit does not exist. So the limit exists if I can show that this mechanism is true for any epsilon. One more time, for any epsilon around 5, I will be able to find a delta around 2 such that when I pick an x value and determine the f of x for that x will always fall within epsilon from 5. That's the mechanism because the limit exists. Here, yeah, I can find infinitely many intervals for which I can find delta, but not for any. And here's one for which I will never be able to find delta. If this is epsilon, there is no delta around 2. So now the definition, we're going to put it in writing, and we're going to also use symbols. Okay, so let's write what we just said. So limit of x plus 3 equals 5 as x approaches 2. I'm going to write the definition for this example, and then we will write the general definition. Now, notice that I have to start with this double equivalency symbol. What does this mean is this. If the limit is this, then the procedure we just discussed is valid. If the procedure we just discussed that we're going to write in a minute is valid, then the limit exists. So it's a double way situation. So if this is true, then the concept we discussed is correct. The concept, if the concept we discussed is correct, then the limit exists. Okay, so double equivalency, because we have to show both ways. For any epsilon positive, of course, epsilon must be a positive number. We will find a corresponding what? Exactly. Awesome. Very good. So I'm not on page 2. It says what I tried to do first. Okay, I'm on page 5. We'll find a corresponding delta also positive, such that anytime we pick x close to 2, so I will write in parentheses the distance between 2 and x must be
So on.
less than, let's go back. So I cannot pick an x here. I cannot pick an x here, but I have to pick an x here, where the distance between x and 2 must be smaller than, what is the width of this interval on this side? So what is this width? What is this width?
2 minus delta.
It's just delta, right? If this is 2 minus delta and this is 2, this must be delta, correct? So as long as I pick an x close to 2, how close? So that the distance between x and 2 is not more than delta. It's not outside of the interval, in other words, correct? Okay, so the distance between 2 and x must be, very good, less than delta. So let's go back for a moment. That limit is 5 implies for any epsilon greater than 0, we will find the corresponding delta greater than 0 such that any time we pick x close to 2, meaning the distance is smaller than delta between x and 2, smaller than delta, the corresponding, or the f of x for this x, the f of x of this s must be
Between epsilon and 5.
must be close to 5, indeed. And in parentheses, I will say the distance between f of x and 5 must be between f of x and 5 will be, very good. Okay, so a lot of words. We're going to write this definition in one line in a second, just one line. But we have to understand it first, and then the rest will be easy. So the limit of x plus 3 when x approaches 2 is 5. I'm just repeating everything. For any epsilon positive, we will find a corresponding delta positive such that anytime we pick x close to 2, any x close to 2, not 2, of course. Maybe I should write that, although it's clear, but write in parentheses, not 2. And we know that. When x approaches 2, we mean x is not 2. The distance between 2 and x must be less than delta. Then, that's what happens. Then, f of x must be close to 5, or will be close to 5. The distance between f of x and 5 will be less than epsilon, guaranteed. So one more time. So when I pick epsilon around 5, I can find an interval around 2 such that when I pick the x value close to 2, f of x will fall within epsilon away from 5. Why? For any epsilon, because the limit exists. Okay, so how do I write this? How do we write this in one row, just one row? So we have to list a bunch of symbols, mathematical symbols. I did not make them up, so we have to understand what each and every one means. So we can write this definition in one row. Okay, so this symbol represents for any, also for all. It's an upside down uppercase A, correct. I'm just looking for the handout that I gave you last time so I can show you the definition. So it's right here on page 7. This is the definition. But I have to explain each and every symbol before we write it. It's going to be very straightforward, just one line. Okay. So that's one symbol. The second one. E backwards, uppercase E backwards. There exists. Next one. A lowercase e backwards, sort of. Such that. Okay, ready? Okay, so here's how we write this definition in one line. For every what? Awesome. There exists. I will be able to find what? Awesome. Such that. Here's how we write the distance. When I pick x close to 2. 0 less than x minus a less than delta. So I'm going to translate this. The distance between x and a is not 0. That's why we don't put the equal symbol here. That's what this means. I cannot pick x to be 2. That's why this does not have the equal symbols in there. The distance between x and a is not 0, comma, but less than delta. So we didn't finish. We didn't finish, but I want to start from the beginning again. for every epsilon positive, I will find the delta positive such that every time I pick x close to a, not equal to 0, not equal to a, the distance is not 0, not equal to a, but the distance is less than delta, this will imply what? In words, this will imply that the distance between f of x and 5 will be less than epsilon. Oh, of course, our a, in our case, the a is 2. This will imply that the distance between f of x and the limit L, so a is 2 in our example and the limit is 5 in our example, then the distance between f of x and 5 will be
Less than epsilon.
exactly. Here's how we write. I don't have enough room there, so please continue there. The f of x minus L is less than epsilon. So how do we translate this? The distance between f of x and the limit L is less than epsilon. A lot of words. This is much easier than it looks. And let me illustrate again with a function. And we can choose a function from your book if you like. Just linear, I'm fine. If we just master the linear situation, I'm fine with the rest. Okay, on page 117, let's do problem 20. So let's read this one more time, and then let's do problem 20. For every epsilon positive around the limit, I will find the corresponding delta around A, such that every time I pick x within the distance of delta away from A, f of x will be within epsilon away from the limit. Why? Because the limit exists, and this works for any epsilon, any as small as possible. Notice one thing. Epsilon is given to us, or we choose it. So every delta will obviously depend on epsilon. If epsilon is this, maybe delta is this. If epsilon is this, maybe delta is this. If epsilon is this, maybe delta is this or this, I don't know. But for every epsilon, if it's 0.1, I may get delta to be 0.3. If epsilon is 1, I may get delta to be 0.5. So delta depends on epsilon. Okay, so let's look at problem 20. Yes, it's a lot of words, but you're going to see it's very straightforward, I think. Okay, 20. I said limit. As this approaches 10 from either side, from 3 minus 4/5 x equals, and we don't need them to tell us what it is, what it equals to.